Okay. So I want to thank everybody for phoning into this 6th session of the BIM course we're running through IBIU. This is BIM During Construction. So just a reminder, IBIU is an accredited AIA provider for continuing education, and this course or this session will qualify for one general learning unit through the AIA, which is the American Institute of Architects. We're going to focus on what BIM means throughout construction, examining some of the goals that are more contractor focused, and how design firms continue to collaboratively add value throughout the project's lifecycle. We're going to be talking a bit about how furthering BIM doesn't result in increasing scope for any one entity when you're trying to work throughout the collaborative or conglomerate whole. So the learning objectives as a requirement for the AIA, understand what BIM goals are sought throughout construction by the contractor and their team. Understand the impact of scope, schedule, and budget from the designer's perspective. That's a very important one for me. Ability to rationalize lifecycle BIM aspirations against practical BIM application, and understand possible ways to collaborate with various external entities throughout the construction phase. Now, before we get into the BIM recap, I actually wanted to put a poll out. So let me launch it. Very simple, yes or no. Have you interacted with the contractors in the past, either to exchange digital information or engage in model review? And I'll just give a couple minutes here. So you should be able to, on your webinar, just click the yes or no. And it's actually much closer than I thought, which is pretty cool. Looks like the yeses are winning, not to sway any votes or anything. I'll just give it a couple more minutes here. Seconds, sorry. A couple more seconds here. We have about 75% of you have voted. I'll just let it get a little higher. Okay. So I'm going to stop the poll. So 88% of you voted, and intriguingly, 53% no, 47% yes. So that's very interesting. So it's split down the middle. And it was actually what I was hoping for and expecting, because oftentimes BIM is done solely in the realm of design, and the contractor interaction doesn't occur. So the BIM recap. Just a couple slides at the beginning here. BIM, the myth, BIM is not Revit, Revit is not BIM, BIM is not just for architects, BIM is a process. And I think I start every session with that. The term there, the actual action of BIM involving the generation and management of digital representations of physical and functional characteristics of spaces. Another way of stating it, it's an assembly of assets in the virtual environment that are going to be built, and those assets will contain some degree of information. A BIM is also a noun, and that would be the typical model that is envisioned, but it's a file of various formats that contain information that's exchanged throughout the project to support decision-making about assets and places, etc. There's various types of software focused on businesses, governments, people who plan, design, construct, or operate, covering that entire life cycle. And it can be scaled to any project type, thus covering the building, the linear infrastructure, and the systems, the I, the B, and the I aspects of IBI. Collaboration and planning are two very critical aspects of BIM. There'll be a session focused solely on collaboration. I believe it's scheduled in August, so stay tuned for that one. But yeah, it's that connectivity of entities and how we're all sharing and harnessing this information. BIM, as I said, geometry plus data. An asset plus something about it gives you BIM, and that something could be robust and it could be simple, depending on what the purpose is for BIM. It's also geospatially located. So when you think of BIM from the micro world of the element, so you're in the depths of your model and you place a component, to the macro world of where it sits within the world. There is that relationship, and this slide is great, the curb on the bridge, on the streets, on the network. Imagine you're building it, at the table, in the room, in the area, on the floor, in the building, on the street, in the city, etc. And you can just go macro out to the world of GIS. BIM is about information, so the I part of BIM. So you have an asset that's modeled in the virtual model. Its identifier, this one showing the example of an equipment ID placed on the model, can tie it back to other sources of information, a schematic, a spec, an operations manual, a computerized operational screen. All of that ties to the very same singular asset. So it's connectivity of information. Imagine everything around the side there wouldn't be jammed into the BIM model, but would be referenced to and linked to in various means so that that information is consistent and accessible. Now here's where the fun comes in. Why do we BIM? So I think it was the second session we went around this wheel here and we touched upon each of these. The orange ones I describe as the typical ones. When we say IBI does BIM for the most part on all projects, that's really what we're doing. Getting our drawings and schedules, conducting reviews, and visualizing our models. And the visualization can spawn off into our specialty visualization with our entire extended team, global team in IBI, focusing just on visualization, rendering, and artistry. The grayish ones are your typical, when you go to BIM sessions, your clash detection, your estimating, etc. And the green ones are more advanced. Now in the world of the contractor though, those where I've placed the star, that's where their focus is. So they're going to work in collaboration with a designer. So they're going to receive models, hopefully, of some nature, or they're going to receive PDFs and then model from their perspectives in order to achieve some or all of those BIM uses. And then in addition, they'll also be designing items, analyzing items, again conducting reviews, and doing health and safety planning for their sites. And we'll go through some of the stuff that get designed on the contractor's realm as well. But before we go any further, I think I brought this slide up in the first session. BIM execution planning is very critical. 2 sessions from now, we're focusing on the project BIM lead, so that will be a point of accountability to ensure that the BIM portion of a project is scoped, scheduled, and budgeted. But that triangle at the bottom there is so inherently critical to understand that every entity, every division within an entity must have a scope, a predefined scope of why they're doing what they're doing, and it has to work in alignment with the schedule and the cost and the resources, etc. If any one of those vertices break, the triangle falls apart. Quality is this element in the middle, and that's where the BIM portion is supposed to come in and infuse and enrich the project. But it all works together. I'm showing this because you need a plan. You've got to understand the BIM goals and which uses are going to be harnessed, and you have to mitigate scope creep, especially on the larger projects. So for the 53% who answered no, they haven't worked with the contractors hand in hand. This is where on design build, P3 projects, or if you're on the design build, operate, finance, maintain, DBOFM, or any other type of arrangement, you're hand in hand with the contractor, sitting there as an architect or an engineer saying, this is how I design, and all of a sudden the scope and the requirements and the demands and the requests far outweigh the, I would say, the normal path that a design project would take. So you just have to understand this. It's not to say that these relationships don't work, but there's a lot of hardship when there's scope creep throughout the entire process of design. And we'll go over a bit more of this now. So focusing on the contractor, the first thing you'll probably hear is a VDC. So that's caused confusion in that, well, what does that actually mean, and why do we say that, and who is that? So VDC is Virtual Design and Construction. You can Google it, Wiki it, there's pages on this. I like to say it's the contractor's term for BIM. So there's that perception, so the BIM myth. BIM is for architects, BIM is Revit, BIM happens in design. Well, then if that myth were true, we need a different term for what happens in construction. So that's, in my mind, how that formulated. the end of the day, it's all BIM. It's about information modeling. BIM is the overarching process that covers the life cycle of the project. BIM during design for architects and engineers, during construction for procurement, fabricating, and constructing, and during operations to manage the assets of importance on a project. That's where BIM plays its role. There are many BIM terms in the world. I'll show them on the next slide in 1 second. But this VDC term, just equate it to, if we're teaming with a contractor, they will most likely have a virtual design and construction lead or coordinator. And what we want them to do is give us a plan. What is the contractor's intent when it comes to BIM? And that's whether they receive BIM models from the designers, whether they're working to build the BIM models with designers, or whether they just receive nothing from the designers but intend to do BIM. We want them to outline their intent in the same manner as we would want to outline ours in the world of design. Coming back to those BIM terms, these are just some of the various terms that have come around: BRIM, SIM, PIM. It's all about information modeling, and if you want to use the term branding, if you will, it's just about building an information model. And that information model is scoped, scheduled, and budgeted throughout the project's life cycle, where various parties play their role. And then it's about, as I said in that first slide, collaborating and planning. If you know what you're doing and how you're going to do it, and you're collaboratively working together, it's a perfect world and everybody will be happy. So then there's the question of data, and it always comes down to the data. How much data is supposed to be there? This is a diagram I like to show. You have an entity in the model, it's got a connection to some type of a database, whether it's built into the tools or exposed elsewhere, and then linkages to other components or sources of information. So all that stream. And when you're in the world of solely design, the data requirements are design focused. But the potential when you enter into the construction realm, the sources and targets of where this various types of information could be astronomical. I love this slide from Autodesk because it shows in that overall life cycle of information and of the assets. So if you look around where you are today, it's all about the assets and how they're assembled and then how they're managed. Each component is poured, procured, and installed, or just procured as a piece of equipment. We play our little part in the design world. The contractor plays, and it's a bigger part, but it's still a little part in the construction world. And there's all that information that comes together to be turned over to the owner. So when we're working with contractors, we have to understand that it can't be adversarial. It's got to be working together for a collective good, with the confines of scope, schedule, budget, understood and appreciated, and I guess respected is the right word, so that this digital information is what the owner at the end of the day intends it to be or is hoping to receive. A lot of visualization occurs from the contractor's perspective. So they take their tablets, they analyze the projects through their models. This is an example for just status of piping spools on a project. What's delivered, what's not, what has been received, what's in production, what's rejected, etc. They take the information on mobile tablets, they review, they query, they hide and manipulate, they can measure. All of this in conjunction with the drawings that are the form of tender. The contract is based on the drawings. The model is information that they want to use and they prefer to use, especially in the tableted environment. They take engineering data, they package it. So they create work packages, they assign the packages to their sub-trades through subcontractors. They get pricing and approvals and inspections and material deliveries. They assemble, they construct, and then they report back on their progress. They manage the payments both from the owner to themselves and themselves to all their trades. Payments are all based on their progress reports. So this kind of cycle, I show this slide because this is indicative of many of the construction management tools that are out there that to help them, the contractor, to manage this. And it's all based on information goes in, information gets analyzed, information comes out. So this, on one facet you could say, well, that has nothing to do with BIM. No, that's construction management. That's what they have to do. But the BIM model can feed into the input of this information. So how many components, how much dirt has to be moved, how much volume of concrete, therefore how many trucks, therefore how do I schedule it and how does it come to site? And all of that can be sourced or predicated with some informational content from the BIMs. This concept conceptually of a construction overlay model. So this is an interesting approach here, and equate it to, and I try to keep everything software neutral, but imagine your Revit model if you're an architect or building engineer, and you're working live in the model, and you have the contractor saying, well, wait, we want to add these pieces of information, and then we want to sync this to these specific assets. And then we may want to change components, and how that all happens and to intertwine. And imagine what you're using for the production of your drawings and for your own design review is being infused with construction information and swelled, and who knows what could happen. So some applications are trying to take the approach of saying, well, no, take the design model and build the construction data around it, whether it's geometrical or whether it's additional information for specific components. So that concept of an overlay or construction trace paper over the design model. This example here is called construction work packaging, and it's actually it's an application from Bentley that tries to achieve that. So this is something that through discussions with BIM media or BIM forums with contractors, it's how to look at the possible abilities to achieve this concept without infusing everything into one big monstrous BIM bucket that the entire life cycle is trying to touch. And then back to the construction management, they're going to use the information based on the drawings, based on the model, based on components, based on how they sliced and diced the work packaging in order to analyze their performance relative to plan in order to feed how they receive their money and therefore pay out their sub-trades. Augmented reality are some items that have been added to the realm of BIM/visualization to help in the field the visualization process of what's actually going to occur. So whether it's buried infrastructure, new or existing, or whether it's how the models or the new assets will look once constructed on site. It serves a purpose from that perspective. There's also the management of transmittals and information, and that's a whole nother realm of all of the requests, the RFIs, RFQs, the information pertaining to change orders, change directives, how to update that information, and how to ensure consistency of information and where it all is, so that come the end of the day when we're trying to deliver type of as-built information to a client that actually represents what happened throughout that lifespan of the construction. And this is just a Bentley slide with, you can ignore the fact that it's project-wise, but it's that concept of you have work in progress with various tools, you're publishing and sharing, you're reviewing, marking up, and going through that continual cycle. You can have the same process with Navisworks, Navigator, Solibri. It doesn't matter what your tool is, it's that continual information updating, if you will, and ensuring that you're not losing that source of information every single time you mark it up, change it, augment it, and push it forward. And then this concept here, the green is the blue is your construction, and the concept there is again, that continual workflow like the Autodesk slide shows. You design, you simulate, you fabricate, you create, and then you manage as an owner. And you don't want to have these dead ends of information where you just can't find anything at the end of the day. So focus specifically on construction now. So those previous slides kind of lay the premise in my mind where the contractors will come into play and how they'll infuse. These next bunch of slides, we're looking at, what are they going to do? So they're pushing us for BIM. They want our models. Give me your Revit. Give me your Civil 3D. what do they want to do with it? So I'm going to go through some of the items right now. So, and this comes up a lot on our P3 projects. They're going to start by analyzing existing conditions. They're the ones who have to break the ground and understand what's down there so that when they do that, there's no risk for life safety, there's no, they don't break something they shouldn't, there's awareness of what's going in there, and also it feeds into the so that we know what we're designing around. So they get the information, and often it's like in the top left there, just a whole bunch of PDFs that don't know, you can't interpret anything. We could do boreholes, we could uncover, unearth, and look to see where things are flowing and how intertwined the existing content are. We can verify surface geometry to ensure we understand heights and levels and slopes and road versus terrain versus ditch and flow of water, etc. Build a model, so that'll be the first jump into BIM to try to capture that existing condition and make it available as a point of reference for new design work. Then we can analyze and coordinate against new work as it's being built, and then you start to document the data, new versus existing. So that kind of existing condition analysis is very important. Now that's, I'll say, dare I say, the old way. So you want to build models of what you see. We can now use LiDAR or various other point cloud generating technologies where we look, we analyze, and you get 3D point clouds of what's seen. So it's great for what is visible, and you can even get more technologically inclined, start to do infrared sensing to try to understand what is buried, so infrared or sonar to get an undersurface 3D model, which is pretty cool. The existing geometry, the digital DTM is a digital terrain model, that would then be able to feed the existing site into a civil BIM application to allow for further development, which is pretty exciting stuff. With structures, it's a little easier to conceptualize. You get a point cloud, it sees what it sees, whether it's a bridge or a building, it can directly be brought into our building BIM software and act as a point cloud reference for subsequent design. It also allows for the verification of geometry relative to what's in the point cloud. So you can imagine the criticality for trying to fish conduit ducts or just insert new structure in and around the existing. So you can get that precision down to the millimeter, really, when it comes to these point clouds. The typical BIM workflow is continued. So you model, you get drawings, you annotate and document. Now, with contractors, what they tend to do is, even though the form of tender is drawings and specs, they seek the relationship between the drawings and the source models. So they want to actually see, they want to drive around the model, be able to cut it themselves, slice it, dice it, and work package it, but also have the relationship to the source views that would then generate the drawings, both used during design, then turned over to the contractors, and then potentially further during construction. So it's very critical, and when you think about how are you BIMing the right way, and when you turn over these BIM models, they go through a level of interrogation for contractor use that is far above and beyond what we would do for design use. So existing conditions, design coordination, and they want to coordinate on P3s right from the very beginning, making sure things are talking to each other, understanding the relationship with utilities, the geometry of the roads, and then your typical architectural, structural, and MEP. And I like showing this slide because initially it's thought of, well, you're BIMing, there's a building, right? Archstruct, MEP, they make a building, then it goes and interacts. But no, the building is it's not secondary, but it's second in line to coming into the site, understanding the conditions, making sure everything is ready, digging down, interacting with the existing conditions, planning and prepping all of the utilities and the connection points in order to feed up into the building. So all of that is critical, and it's from that perspective where the contractors are looking first. Temporary works. This is something that, it's probably the closest to what we do in the design world. They're actually designing components, which they then need to get permits for, which they then need to construct. And, one of the biggest ones would be, for me, is the shoring and underpinning. That comes, right at the beginning. You walk around any site and you see, look, they're digging a 2-3-story deep hole, and they got to hold up everything around. That needs specific design, and usually they need to take the design models, use them as a base for reference in order to design and model all of the conditions around the building itself in order to support the site from collapsing and thereby causing collapse of the adjoining infrastructure or buildings. Pour breaks is another one I wanted to talk about, because this has come up in my career so often, where they say, oh, you've modeled the wall. And I say, yes, I modeled the wall. And then they'll say, but no, this wall has to be poured in 100 pieces. Can you model the one component in 100 pieces? And normally the answer is no. And we need to be very clear. That would be a scope creep example, where in the perfect world, they would take my 100-meter or 300-foot long wall, and they would apply the pours onto that component. That's that concept of the construction overlay. So a lot of the software vendors are understanding that there is this dialogue between designer and contractor. I want to place a 500-foot long pipe. The contractor wants to see a pipe relative to the available spool lengths, for example. So we want to have that dialogue. We want the models to be able to accommodate both design and construction. And there's an intriguing trick to make that happen, or effort to make sure it's working well. And then they coordinate the support systems to make sure that, as walls are being poured, they are supported, and whether they need extra supports in order for the concrete, until the concrete cures, for example. They've got to design all of that content. They've got to design their cranes. They've got to design how they're moving materials to and from various levels of the buildings. They have to design how they're interrupting the existing infrastructure. So traffic staging is a great example, but you've got vehicular traffic, transit. You may be interrupting underground passageways, pedestrian sidewalks, and they've got to manage and design how they're going to fix and adapt and then refinish after the fact. They review from a constructability perspective, and they want to do this as early on as possible. So they want to understand what's happening during design so they can figure out how to work in the constraints of the site, because usually the sites are somewhat constrained, how to get materials in and out. So where do they stage materials? Where do they put the trailers? Then how do they get the cranes in? Once you start building, how do you get the crane out? And all questions like that. They want to pose them, understand them. To do that, they kind of need to be aware of what does the built form look like? How does it interact? Are there buildings with underground tunnels? Are there major underground utility lines connecting on a treatment plant, connecting filters, connecting various treatment buildings? Is it a transit system, so going from building to building through a constrained corridor? They've got to understand all of this so they can plan the site, plan the assembly sequence, so what components will go up first relative to a schedule, and plan the excavation. If there's material to excavate, where does it go? Can it be repurposed on site? Can it go to another one of their sites? Does it have to be disposed? Do they have to plan for that and cost it? 4D, this is probably the biggest BIM use that the contractors will harness. The biggest. Now let's go with that. So, they will have a construction schedule, and they want a 3D model to bridge the 3D model with their schedule to equal 4D simulation. It's the most industry standard, quote, D term. So 3D is length, width, height. The fourth dimension is time. They run their simulations like shown in the bottom right there, and it allows them to show, this is showing at a macro site level how the site will be populated over time. They could do it at the building level. They could do it at the material level. So it could be, how's the concrete going to be poured over time? How's the steel going to be erected over time? They can get as finite as required, focusing on trades, focusing on materials, or focusing on the model as a whole. This is a video, like an old video I've had for a long time, as you can see by the date. But because it's a webinar, I just took some snaps of it. So very simple, showing the foundation, going up to the superstructure, level by level, how it will be built. It's quite rudimentary, but that's the concept. So to facilitate that, they need a model that can be animated against. And whenever I present this animation or this video, I'll say, just imagine if I modeled those red columns from ground floor straight up to the top as one component. Then you can't really simulate it based from the BIM model. And there's always that dialogue. So, I would say best practice, you want to model as it should be constructed based on our knowledge as design practitioners. So I know that there's never going to be a 10, 15-story column, so I'm going to model that column as it should be modeled. But if I modeled it as one component, my drawings would still probably look okay. My plans, elevations, and sections, my visualization would probably look okay. And in design review, it would probably look fine. So you've got to think relative to those BIM uses. For the sole sake of my work, I'd probably be okay. But knowing that somebody may want to take my model and do more with it, would it hurt me to model that column, one column per floor versus one element for the entire floor? So we ask those questions, and usually it's, yeah, it's okay. It's not too much additional effort, and once you do it once, you can copy up and away you go. So they're all questions worth asking. The other major BIM use is the quantities. So they want to know how much material there is in that model. Now this is so heavily dependent on good data in the BIM models. And this is probably the biggest point of friction where you get, hey, I can't simulate against your model, or hey, I took quantities of your walls and your walls aren't showing up right. Well, that back and forth dialogue, is it scope creep? Do my walls have to show up right for the contractor's quantity? Is it enough to just say, hey, here's the amount of walls I have, you delineate materiality, you delineate how it is. So it's an interesting dialogue, which is why we stress BIM execution planning. And oftentimes, execution planning doesn't happen early enough. So we're not contractually bound to say, you know what, I will model, I must delineate material because the contractor's going to take quantities. I'm not going to take quantities, but my components have to have materiality. And if that's spelled out in the contract with the BIM execution plan, then there really is no question. We'll just do it. It's when it's not, and we try to be as efficient as possible, and then the contractors try to harness our items. An example here, just our quantity takeoff, that's what QTO is. That's, I believe that's becoming an industry standard acronym. So they take the model, they get a sum of the components, and they can report on it, understand it, feed it into their cost estimate, and also feed it into timelines. Same with the linear infrastructure. They take quantity takeoffs of your piping, your surface alignments, your cut and fill calcs, etc. They can take that information from civil models and analyze it accordingly. They can take elements of a road corridor, so they understand based on the length of road and the cross section of the road, how much quantity of each of each component of the road there is along the overall alignment, and then report on it accordingly. Very powerful tools, very powerful abilities to be able to achieve this. An example just of some quantity reports that I've done in my past as previous projects, you click the button. That's really all it is, and that's all it should be. And this is where it takes a while for, and I want to say it's a comfort level for the information that comes out. So here I press a button, I get a list of concrete types. So is it a slab, is it a stair, is it a straight wall, is it a curved wall, etc. Sub-volumes and an overall volume of concrete. If I know that this model is a good model, I can say, yep, there's definitely 13,351 cubic, I think this is yards, of concrete. If I know that it's a bad one, and in the past, I've been burned on a project where there was a 3-foot diameter pipe that was encased in concrete. Well, the concrete modeler forgot to cut the hole for the 3-foot diameter pipe, spanning across the entire length of a facility. That was a lot more concrete in the estimate than there needed to be. So things like that happen. Now, you can imagine the level of coordination required to get something robust. In that, you know, if we had to cut out all of the embeds, cut out all of the penetrations for ducts, for piping, for major conduits, or for large collection of small conduits. Say it's a 50 millimeter conduit, but I have 15 of them running through the floor. That's going to be quite the cutout in the floor, and that'll have an impact on my concrete quantities, for example. Same with steel. I can analyze the model, look at all of the steel quantities, look at types of beam, and you can see the beam sections in there. It gives me my steel volume, my pounds of steel, decking, pipe supports, etc., and it'll give me an overall volume of steel. So information that, or weight of steel, information that can be used for initial takeoffs as well as for in-depth analysis relative to the schedules. Same with mechanical ductwork. I can analyze what type of mechanical equipment do I have, how much length of duct I have, so the width. So this is an Imperial project, but 18-inch by 42-inch duct, length 172 feet, and away we go. So all of this can be pulled out of the models. It's all dependent on it being modeled correctly, obviously. Types of lights. So we put the lights in the model, and we just say, tell me what you have. Now there's an interesting here, because this was a project where I actually configured the information to give me what you see there. As a base, you could just say, or you could just get, in my model, I have 726 light fixtures, and that's it. Then the contractor may say, well, that information doesn't help me. I need to know types of lights or types of fixtures. So on this project, because it was a design build, we actually were able to plan for that, and instead of just placing a fixture that's called a light, it was a fixture that was a 250 watt blah 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 light, and it was able to actually identify that then, and we were able to quantify it at a far better level of detail from an informational perspective, but the contractor was then able to take those quantities and apply. But if that's not in the contract, and that's not defined as a BIM use, don't hold yourselves accountable for information you may or may not actually need in your model. That's always the question. Again, different analyzing light types. And then the last one here, you know, you can quantify anything. So I remember this project said, are we really going to model the telephone jacks? But at the end of the day, it wasn't anything complicated. It was a very thin rectilinear form that was placed in the model, and we called it telephone jack. And then we just placed it where it was supposed to be placed. So visually, we were able to do visual design review. If there was a fixed component or equipment put in front of a telephone jack impeding the use of it, we were able to see it, but we were also able to quantify it. So the contractor loves getting information like that when it's required, when it's able to be given, or when it's required. Trade coordination. This is another aspect, and a heavy one from a contractor's perspective. So they want to take the design models, compare them against fabrication models, for example. So the steel fabricator is the best example. They'll go in and actually take a Revit model, pull it into a tool like Tekla, add connection details, add true sizes, add anything else that otherwise wouldn't have been represented on the design side, fabricate the components, build the shop drawings, take professional liability by stamping, deliver to site for steel erection. And the contractors will want to compare the intent versus the fabrication, analyze any potential conflicts, because now if something's been fabricated, the geometry may have shifted, and therefore there may be complications or interferences with other components that are not steel. So they're able to look and say, do I have a design versus fabrication clash? So something's changed. Is it a hard clash? Is it a soft clash? Has something moved into a reserved space for barrier-free accessibility, for operation of a door swing, for operation of a mechanical valve? all a good question, and then they report against that accordingly. Clashes are very heavily done on the contractor side. On P3 projects, when we turn over digital information, they're actually running these clash reports right from the very beginning. So it's very interesting when we're at 30 to 60% design, being told, hey, your stair is clashing with the columns. And then you say, yeah, but it's being designed. So, there's those dialogues that are fun, but it's very important to understand from the contractor's perspective, you have hard clashes. Pipe is interfering with a curtain wall, as shown here, or a pipe, or with the beam there, actually, that's a big clash, or a duct is hitting a beam, all those good ones. But the soft clashes are ones that people really don't realize, that I have a piece of equipment, there's a requirement to have a 4-foot clearance around it, either for safety requirements or for just operational requirements of the equipment itself. And those reserved spaces are actually finding their ways into BIM applications, where not only do we now model components, but we model the spaces that cannot be touched. So then therefore they are pegged as interferences if there's hard components within the soft spaces. And then we've got schedule simulation clashes. So as they attach a schedule to a model, process the simulation, they'll then identify that as components are moving into and out of the space, we could have a clash. An example on a previous project I had a generator room, and as the building was assembled, they realized that once the walls went up and the doors were cut out and everything was fine, the generator would not be able to pass through even the double door as delivered. So therefore we had to augment one of the louvers to make it a removable louver. So it allowed us to finish pouring the walls, assemble part of the louver, deliver the generator when it was ready. So we didn't want to delay the schedule and don't put the walls up until the generator got there. So the walls went up, roof went on, everything was good. They were able to close it up for the winter, remove the louver when the generator was delivered, and insert the generator into the building through the louver, and then replace the louver. And the louver itself being removable was the ability to access and get the generator in and out if they had to. And that was all discovered through a schedule simulation based on how they were going to, they had to close the building relative to weather as opposed to relative to delivery schedule of the components. So that was an interesting case that resonates in my mind going forward. Another video that I would show, but essentially you're able to swing through your models, identify your clashes, you see what component is clashing with what, you can report against them, you can assign those clashes, understand them, see what the items are, deliver them to a target audience in order to resolve. Fabrication drawings are a byproduct of the efforts of the contractor. So they will take design drawings that potentially look like what's on the left there, and they will start by, again, isolating the work packaging, isolating the components, understanding the assembly of the products. Here it's showing piping spool drawing. They'll analyze how these components will come together. The steel components will then be sent off to the fabricator. The fabricator will be focused solely on that element. And then that element will be fabricated, delivered to the site, assembled relative to the other components, and then located relative to the conglomeration of all the assets. So that concept, it's fragmenting BIM into its component elements, because that's what the contractor has to do. It has to understand what's in that building or what's in that linear infrastructure as a whole, break it down to the asset level, and then build it back up in the built environment. The other thing they can do is that on the BIM uses machine control and site verification. They can take digital terrain models and actually analyze existing built geometry. So whether it's the site or whether it's taking the BIM models, the floor flatness is one of my favorite ones. They can take the design intent with respect to floor slopes and then analyze whether or not they achieved that after the pour. And if you have high spots or low spots, they can then work on, well, they can declare whether it's acceptable and fit for purpose or work on a remediation. Verifying geometry in the field relative to geometry in the models, and that could be used with augmented reality, putting the BIM model in front of what's being built, using tablet devices. Just solving complex issues. Okay, go to site and you look at what's in the drawings and you look at what's happening on site and something doesn't jive. How do you fix it and what do you do? An example from my previous work, they couldn't pour the concrete in the forms because the rebar was spaced too close together. The aggregate couldn't fall. And so the aggregate was getting stuck on the rebar and only the liquid was falling down into the form. So that was a very interesting one, and it called for a little bit of a concrete redesign for the actual mixture to use a different strength concrete, different sized rebar, sorry, different sized aggregate to fit within the already installed rebar. So it was an interesting, complexity there that oftentimes, in the design world, we may or may not see those types of items. Just counting the stuff that's been installed. So you've ordered and procured a bunch of components. They get scattered across the site upon delivery, and then you want to verify that everything's been installed. Everything that the contractors paid for, they want to understand where the stuff is supposed to be in the design and where it is in the physical form. So they could use just field count verification visually. They could use barcode technology if they choose to go that route. The excavation volume scanning, I've seen this happen taking a civil BIM model. We've got a digital terrain model, you've got your curvatures, your slopes, etc., everything modeled, and you have the various stratifications of the site modeled and identified as well. And depending on your cut fill requirements, they can then scan the site to see if the site is representing what is in the DTM, and then they can do comparative analysis to ensure that what they're doing on site is occurring relative to the design. And I don't know if anybody's seen on LinkedIn, there's a pretty slick video where they're just showing in a sandbox, you dig through the sand, and a augmented reality projection of the BIM model is showing what you're digging into relative to water levels and underground infrastructure. So it's kind of cool where the technology is going. Now, that was in a sandbox. One day it'll be on an entire site. So then schedule control. So previously we talked about that 4D schedule. They'll have that, but now they want to verify that against their actual schedule. And that picture of the post-it, and that's what they do. They'll have a schedule in the trailer, and they want to analyze, are they meeting what they were projecting? And if not, then does that have to be adjusted? Again, the BIM model is part of the backbone of this, and in the context of all these examples, just keep thinking back. If you turn over the model to them and the model's not good, and you haven't signed any waivers for use at your own risk, what does that mean to us? Or in the P3 world, as we're continually sending them information, they're doing this relative to design information that may only be at 30 or 60% complete. So look, the footings might be at IFC, but the superstructure nowhere near, for example. They can do deficiency lists. So we've had, there's the concept of punch lists, so they can go around site, identify items that are as designed and as required for installation. They can identify what isn't, tag that in the BIM model, feed that back to one common database, allow for visualization of items that have to be replaced or where the comments are, stuff that's back in the detailing phase, etc., all relative to a visual locational model, which is using the BIM model as a base. And then, of course, we've got as-builting and facility management, or ASBM. So, as we go through that construction phase, if that model is continued and furthered, it is then the source of the single source of truth for as-built correct information, which can then feed into our as-built drawings, but more importantly, from an owner's perspective, feed into this FM model concept. And this we'll talk about on the next BIM session, BIM during asset management. And it's, we're getting to the, I want to say, a little more rarer of instances where, in the FM world, the owners know there's a BIM and they want it. There's a lot of effort to make sure that through that design and construction life cycle, they're able to receive something that is actually in a usable state. When working on these FM models, or models to be harnessed during as-built and FM, it's so critical to understand that there's information once you hit tender. And this example, so let's say it's a design bid build. Stuff happens, you make an RFQ and things change. And this was just a project I worked on previously. The support of this element was redesigned. You sketch it out, the contractor can go and bid it, it gets entered into a change order, and the contractor proceeds. But if this model isn't updated, and therefore the drawings associated aren't updated, that sketch, if it's in a document management system, maybe you'll find it. If not, it'll probably get lost throughout the 2 to 5 to 10 years of construction, and then what do? The model would never be updated. So this design constructability review, this is the last one, and this is very heavy, right? So as you're going through the process, it's taking drawings and understanding what the intent is, how they're meant to be looked, how the components come into place, and how to actually interpret what's being shown on the drawings. And there's various ways. That was just using still imagery. This is a 3D PDF where on a previous project where we had to model the rebar itself, and it was to show and give an understanding of how the design could possibly work. So they took a component, they did a quick model of it to bring an understanding of it in an area of concern to a level of development that we would never model to this perspective. Even the contractor wouldn't. But in a design build project, there may be instances where we have to show some type of detail. Just reviewing the model as it's being developed in a live environment. This is a MicroStation example, but it's the same concept, whether you're using a Bentley product, a Revit product, ArchiCAD. Take your model, slice it up, understand how components are meant to be harnessed, utilized, interacted with. 3D PDFs, take pieces of a model or a space, show the layout of it, drive through the spaces, understand, get design reviews to occur during the construction phase. So if I have to make a change to a component, understand what I'm changing and why I'm changing it. If we have to get stakeholders to understand, or clients, all of these tools are at our disposal. So the ultimate is your model is becoming reality. And when BIM started a decade or so ago, maybe more, a decade and a half, it was just getting to the BIM stage. But these are examples. So this first example is from my previous work where the model actually is what's shown in reality. And we're seeing more and more instances of this where you can take those BIM models, whether you're the designer or the contractor, and actually start to see those in reality. So this is our Ajax Go station. And when you see this and you're able to look back and forth between what's in that BIM model and what's actually being built, it's quite impressive to see that these are coming to fruition. And when I look at this one, sometimes I forget which one is the BIM model, and it's the top left there is the BIM model, the bottom right is the actual building. But sometimes it's hard to tell because they're just so accurate and representative. You can also bridge actual construction and rendering side by side, and this one was done from our US West region. This is pretty slick as well. So as the sites start to be constructed, they're feeding into the BIM model, and you can just fuse it together to say, hey, here's what started, here's how it's going to look, and here it is in context, and you can start to bring fusion to the real and the designed in forms like this. And with that does finish today's session. So there was a lot in there, and I just wanted to remind of the curriculum. We're just here on the 6th session, BIM During Construction. Asset management will be in about 3 weeks, And then in August, we have BIM software at the start of August, collaboration at the end of August, and I'm inserting in a BIM and legal in the middle there. So we'll have 3 sessions in August, and then the rest following. So with the limited time, we have 5 minutes. I'm just going to pop out to see if we have any questions. And what I wanted to remind everybody, please make sure to enter your AIA number. I forgot to say that at the beginning. So if you want automatic AIA accreditation, please enter your AIA number into the question panel right now, and it'll be placed by your name when I take the attendee report. And if are there any questions, please enter them into the question box. And while if anybody's typing questions, just also note if you are a OAA member or any other architectural association in Canada or the UK, they will automatically, once you receive the AIA certificate, you can just manually enter in your credits on the continuing education forums. So I have a question. Does BIM impact the possibility of contractor gotcha incidents? That's a real good question, and you know, from my experience, I would say no more so than the contractor. You know, if they're really in tune to your drawings and your CAD files, they'll do that. They'll try to get you regardless. I've seen on P3 projects, I've seen that happen more so, where the contractors will say, hey, you promised a level of detail or level of development 300. I'm looking at your BIM model. I'm not seeing X, Y, and Z models. Why not? Or this isn't what I expected. I'm going to now try to squeeze you to do more, etc. So we do see that, which is why for me it's heavily important that the project starts with a strong scope, schedule, budget. Because you know, if you know your scope, then you can say, you can easily respond saying, no, or you may be correct, but it's out of my scope. I can address that for a change with a change order, or that's not in my scope. You have to deal with it, or it could just be, yep, that is something we need to fix. So like depending on the nature of the gotchas, yes, you know, so like a wishy-washy yes or no answer. What happens when the project manager's decision to go from BIM down to CAD due to staff's limited skill and the project does not have enough budget? That's not good. So yeah, so there I would say you will have a severance of your intelligent information. So if, again, back to scope, schedule, budget, if the scope of the project does not require a BIM turnover, and then the decision is to, okay, we're going to cut the cord on BIM and proceed only in 2D, are we cutting the cord on our efficiencies? So I would say if the scope then is really just design, does cutting BIM help us? And if we don't have the, you know, if it's about staffing and skill set, then I would say let's open that dialogue, because are there people in IBI that can help, or are we really we just don't have people and therefore we're not able to facilitate. But that does hurt us when we go down to CAD. Then we can't harness BIM for as-built. The visualization team doesn't have the most accurate possible BIM model in order to advance their visualization. Forget about quantifying, forget about any potential downstream use of BIM. And then even worse, if we win a renovation on the project, we would know that the BIM model doesn't represent what's being built. And I've been on a project like that. Okay, during construction, contractor will build their own model. If so, what's the difference in their own model and the architectural model? So if the contractor is building theirs, and I hear this often, the contractor says the architectural model sucks, or the design model sucks, so we're going to build our own. And it's often because they'll delineate theirs to a greater component level delineation than we would in ours. And I just like the concrete walls. We'll model a wall, they may model 100 pores. Or we're using a classification system. So if you were on last session, I talked about uniclass, uniformat, omniclass, master format, uniformat, all the various, I didn't dwell on them, but there are those classification systems. So if I'm a contractor and I'm using a tool like Timberline, that says, you know what, let me scan a BIM model and look for uni-class codes. And I scan your model and you don't have any. Therefore, the automatic connections between a BIM model and Timberline are potentially hampered, and I may have to do additional work. So do I do the additional work, or do I scrap it and remodel it the way I want to see it anyway? So I get component level delineation, I may get component data that I want, and then I can just take in the design models and do a comparison. So that's been the biggest reason that I've seen, but more so I've seen contractors just start to push designers more and more to say, you know what, you're doing BIM, I don't want to start over, give me your BIM model. And I think that's a better scenario. Take my, quote, design BIM model at a level of development 300, further it, make it 350 ready for procurement and installation, and then further it, make it 400 for as-built. I think the hard part is when they say, I don't want to do my own model, I want to feed into your model while you're still designing. That one sends shivers to me because I still don't know how that would best work. So, okay, any other, good questions by the way, that's excellent. Any other questions before I stop the broadcast? Okay, well thank you everybody, I'll have the recording up very shortly, and thank you for everybody here who's entered in the numbers. That's perfect. That's what we have to send. If you are in a room with a sign-in sheet, again, yeah, scan it and send it to ibiu@ibigroup.com. And I'm looking forward, and hopefully you can all phone into the next session in about 3 to 4 weeks' time. All right, have a great day, everybody. Thank you.